after you have been able to draw a scatter plot, it is very common to fit a non-parametric smooth curve through the data, especially when there is no obvious candidate for a parametric function, which I have done previously. So with fitting a non-parametric curve through a scatter plot, R offers a range of options. One of the options we can do is we are going to use 4. We are going to use the lowess, the loess, the GAM, and then the linear model. So the lowess is a non-parametric curve fitter, and then the lowess is a modeling tool for prediction, and then the GAM, which is the generalized additive model, we also use it to fit a generalized additive model. I will show you how it is done, and then I'm also going to show you a linear model for regression, for polynomial regression, and this one too, it fits a linear model involving powers of x. So let's get started. So now we have our data over here, which we use the reader table, and the name of the text is called text jaw, and then it is a TST extension. We have the header, which is true. That tells you that the names of the headings are already there. We use the attach functions to make it calling the names become very easy for you, and then we use the names function to also call the names so that you will know what we are actually doing. So let's run it quick. We run this, then we run this code, and then we run it. So sometimes you might want to view the data. So what you have to do is use the view function, and then you say data. So you do that, and it becomes very easy for you to view the data. You see the bones over here. So the age here, and then we also see the age is the response variable, and then the age is a explanatory variable, and then the bone is the response variable. So now let's get started. So we are going to use the lowest, but before that, because we are going to do 4 presentations, let me just explain how we do that. If you want to present graphics, if you want to present a graphics, this is let me put this code here and then explain. So this one is by default. We use the par mf row, which the mf row is, it means that it is the name of the mf row is multiple frames by row. So multiple frames by row. And then by default, if you use 1 and 1, it gives you the entire screen over here for your plot. If you are using this code, it means that you want to plot 2 plots on one screen. So you have 2 plots on a single screen. If you want 4 panels of plots on a single screen, you might want to use this one for the columns. Sorry, the row, which is 2, and then we want 2 for the column. So it's going to give you 2 by 2. So it's basically the same thing like this. So now let's run them and then see how we are going to use it. Because we need this one. This is what we need, because we need 4 panel of plots on a single screen. This one, we want to use this one. So we run this one. So after we have run it, now we want to use the lowest method. So the lowest, the first thing we have to do is to plot the graph. Then we use the line to do that. So now let's do with the lowest. So the lowest, you might want to plot it. So we do it over here. So we plot the age, which is the explanatory variable, and then the bone which is a response variable, and then we use PCH, which is 20, and then the title should be lowest. So let's plot this one and see. Let me see. It cannot be. Oh no. That's not important. We run it over here. So you see it over here. The next one, we are going to see it over here. Another one, you see it over here. And then the next one, we see it over here. So after we have been able to do this, another thing we want to do is to draw the line. So the line, by using the lowest, and then we want to choose a color which is red. So this is the code we are going to do. So we do that. We draw the lines, which is here. And then we use the lowest function, the lowest on age and then bone. And we are choosing a color to be red. So let's run this one too by pressing Command plus Enter. So when you do that, you can see everything over here. So here, this is you can see it. So what are you going to explain about this plot? So this one, we can say that it is a reasonable fit overall, but it has a poor descriptor of the jaw size for the lower 5 edges. So when you look at the lower 5 edges over here, the line couldn't pass through well, so it couldn't predict the jaw very well. Another thing we want to use is the how do we call it? The lowess function. The lowess function, and then we use the low function to predict the jaw size. So this one is a prediction function. So let's look at how we will also do that. So we are going to use the lowess function. So it is also so let's look at how it is done. It is very, very easy. So the first thing we have to do is to plot it. Then we write we do the model. Then you select how we are going to draw the lines from 0 up to 50. Then we write our prediction model, how we are going to predict it. We're going to predict the model and then the data frame, and then we will so let me show you how it is done. Very, very simple. So the first thing is that we plot it. So let me just plot it over here. This code. So we plot the age and then the bone, which is this, by using the lowess here, and then it comes here. Very, very, very nice. Another thing is the next thing we have to do is by choosing the model. So which model are you going to do? So let me show you the model. The model is here. We use the model, so we call it model. So we say the lowess, and then we are using the response variable, and then we tell that it's on the explanatory variable, which is the age. So you do that. Then after you have done that, you might have to select how you are going to draw the line from where to where. So it's from 0 up to 50. So let's assume that we call it XV, and then we select it from 0 up to 50. Then we run it over here. After you have done that, we have to choose how you are going to predict the data. Let me show you how it is done. Very, very simple over here. We use this code to just run it. Let me explain. So you're going to predict the model. What model is that? This is the model. This model. Then our age, the age should be the it should be equal to, because it is the age which is going to the S column. The age is supposed to be the X, which is from 0 up to 50. So we do that and then we run it. After you have done that, now we want to draw the line. So now the line is going to be XV and then YV, and then we choose the color. So it's very, very simple. We are going to use a red color to do that. So we can say X here, over here. So XV, YV, and then the color is red. Let's do that and see. After you have done that, it's drawn the line very, very well. Now, it seems a little better than this. So how are we going to explain it? If you look at this, how do you explain it? So you can say that this is much better at describing the jaw size of the youngest animal, but a slight decrease for the oldest animal, which might not be realistic. So another thing you can also do, another thing we can also do is the next thing is the generalized additive model. So that one, let me show you how it is done. So we are going to fit the bone as a smooth function of the age. So we use a package called MGCV. So let me just do that over here. So let me give more space over here, then do it over here. So you can install it. I've already installed it, so I don't need it. So but if you want to do that, you just use the install package MGCV. Then you call for the library. The library is very, very important because you're going to use something called GAM, which is the generalized additive model. So we run it over here, and then it's fine. Just it doesn't matter. So after you have done that, now what you have to do is we draw the plot. So so we are going to draw the plot. Okay, it's here. So the plot, the age, the bone, and this. So I mean, you can use the name that's which is the main. Then you say, oh, okay, generalized. Oh, sorry. Additive model, which I don't think is important. I mean, it's just we just want to do that. So we do that over here, which comes here very, very nice. Generalized additive model. So after you have done that, now what is the model? So the model we call GAM, which I've already said. So we are going to use the GAM on this. Then we tilde the bone on then the age. So we use the generalized linear model, which is the GAM over here. We tilde it on SH. So we do that. Let me show it over here. So you do that. So after you have done that, then you have to write the prediction line. So what you might have to do is to do that. And it is very, very easy. Another thing is, that one too is also very easy. So you use this code. So we just want the YV, we are going to predict the model, and then we list the age as is from 0 up to 50, which is XV over here. There is no need to bring it. So you just do that too. Okay, so let me just run that one too. Okay, sorry. We run that one too. After you have done that, now we can now go ahead and then draw our line. And then the line, yeah, basically we are using the same thing. So you just do that, which is the XV, and then the YV, which is this is the YV. This one will override this because we just run this. So, and the color is red. So we do that. Look at this one too. This one, what are you going to say about that? You can say that by looking at this, this is almost the same as the lowess. The lowess. Okay, so and finally, what you have to do is by using the polynomial function. That one too is also very, very simple. You have to draw the plot. After you have done the plot, then you write the model, then you predict, and then you write the lines. This is almost the same thing, but let's see how we are going to write the model. So let me just bring it over here, give more space. Push it over here. So okay, now look at it. We plot the age, which is the explanatory variable, then this is the response variable, then the PCH is 20, which is the plot character. The main is cubic polynomial. Now we write a model. So the model is that linear model. We are going to use the response, then we tilde it on the age. So the age is the first one. Then this is the quadratic one. So we use this for the quadratic, and then we can also use this for the cubic. So this is the cubic. So after you have done that, so let's plot. So it comes here like this. Look at how everything is looking at over here. So now we write our model, which is this, which is the cubic model. You can also do a quadratic model by deleting this one. If you delete here from here, it becomes quadratic. But here we are looking for the cubic polynomial. So we do that over here. After you have done that, the next thing is to predict. And then it is basically the same as this, the same thing. So you can just, let me just copy this code and I just paste it over here. It's basically the same thing because we are using the same. So this model is going to override this, and then the age, we are using the same age, and then XV is already here. So that one to run it. After we have run it, then we can now draw our line. So the line 2 is basically the same thing. So let me use lines. Then you say XV, YV, and then we can say the color. to be red. Very simple. Then you do that. So it comes here. Very, 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 very nice. So you see, this one too is also it's so what we can say is that this line is more curvaceous than we really want, though it is a good for young animals, but it's rather waving where we might expect to see an asymptote. So, you know, like for this one, it tips up to the end, whereas the last two smoothest tips down. It tips down. So I think this is all that we can do to fit non-parametric. So they are all four. They are four. So you choose which one is good for you. To me, probably I would choose the lowest because you don't need any function. You don't have to install any package. Even though the generalized additive model also is good, but I mean it is up to you to select which one you want. So thank you very much, and don't forget to subscribe to my channel.